The distributive property is used all the time in mathematics. You might have seen it before, you might not recognize it, but you may have seen something that looks like this. 3 times 78. You might have been asked to do a question like this before, and you might have done it with a grid, set something up, a process, longer process. But another way to look at this multiplication would be to say that this is equal to 3 times 70 plus 8, because 78 is 70 plus 8. And one way to do that problem would be to say, well, that's 3 times 70 plus 3 times 8. 3 times 70 is 210, and 3 times 8 is 24. So the answer to this would be 234. What we've actually done is applied the distributive property to this expression right there. Another way you might have seen the distributive property is in a question like this. Find the area of a rectangle whose width is 3 and whose length is x plus 2. So we'll say that this right here is x plus 2. We don't really know what x is, but we'll just give it a distance. And the height is going to be 3. So how would you go about finding the area here? One way to think of it is x plus 2. That line represents the distance x plus 2. You could break it apart and say this first part is x, and this next part here is 2. So put a dotted line here. The area of a rectangle is base times height, so the area of this first rectangle right here is 3 times x, and then the area of the second rectangle right here is 3 times 2. So the total area of this rectangle is going to be 3 times x plus 3 times 2. And one way you can undo that is to say that that's equal to 3 times x plus 2, which would be multiplying 3 times x plus 2. So that's another illustration of the distributive property. What does the distributive property actually say? It says this, and it looks quite complicated, but it's actually saying the same thing 4 different ways with slight variations. The first line says that A can be distributed in and multiplied by A, B, and C to get AB plus AC. And all the second line says is it doesn't matter which side of the parentheses A is on. It doesn't matter if A is on the left, it could also be on the right, and you can multiply it inside like this, and you get the exact same expression. Similarly, it doesn't really matter if there's a minus sign in here. You just have to make sure that whatever is the minus sign is attached to, that you make that term negative. So when you distribute here, A times B, it's going to be AB, but then you notice that A times negative C is minus AC. And then similar to the first situation, it doesn't matter which side of the parentheses A is on. It could be on the left or the right in this case. The distributive property still applies. Before we get back to doing some more distributive property problems, we need to understand the meaning of 4 different terms: coefficient, like terms, constant terms, and what it means for something to be simplified. In a term that is a product of a number and a variable, the number is the coefficient. So for example, in this term right here, there's actually a number there. There's an invisible number. There's a -1. This term is actually -1 times x. And in this case, the coefficient is right here. Over in the second term, the coefficient is going to be the 3, because the 3 is the number that is getting multiplied by a variable. The second term is like terms. And like terms are terms in an expression that have the same variable raised to the same power. Same variable raised to the same power. So let's say I had x squared and 2x squared. Notice that you don't need to have the same coefficient, you just need to have the same variable, in this case x in both, raised to a power. It doesn't matter what the power is, but they have to have, the same power. They have to have the same power. So in this case, you have an x squared, one of them, and a 2x squared, which is 2 of them. So these would be called, these two terms right here, x squared and 2x squared, these are called like terms, because they have the same variable raised to the same power. Constant terms are terms that do not have a variable attached to them. So for example, if I gave you the expression 3x squared plus 9x plus 2, you have 3 terms there, and one of them is a constant. In this case, the constant term is the 2 because there's no variable attached to it. And then what does it mean for an algebraic expression to be simplified or most simplified? And that means the expression has no grouping symbol, so no parentheses, and all like terms have been combined. So again, a simplified algebraic expression will be one with no parentheses and all like terms have been combined. So let's do two questions. In the expression 4x squared minus 7y minus 8, what is the coefficient of the x squared term? So you have to find the x squared term, which is right there, and find the coefficient, which is just the number in front of x squared, the variable term. So in this case, the coefficient of x squared term is going to be 4. The second question asks, what is the coefficient of the y term? So you find the y term, which is right here, and the coefficient there is going to be -7. That's the number in front. Second, what are the like terms in the expression -6 minus 3x squared plus 3y plus 7 minus 4y plus 9x squared? So you look for terms that have the same variable raised to the same power. In this case, I see a -3x squared and a 9x squared. These would be like terms. And also, I see a 3y and a -4y. Those would be like terms. You can also technically say that constants are all like terms, so you've got -6 and 7 right there. So those are your like term pairings. Those terms can be combined. So how would we use the distributive property to rewrite expressions without parentheses? You need to distribute into them. So in this equation, 5 gets multiplied by w to get 5y, and 5 gets multiplied by -8 to get -40. In the second equation, 7 gets multiplied by y to get 7y, and 7 times 19 comes out to be 133. Last, we have y times 12, which is 12y, and y times -x, which is -xy. As a side note, you always want to put the number coefficient first, and you want to, generally speaking, put the variables in alphabetical order. So in that term right here, you have an x and a y, put the x first. So now let's simplify and combine like terms. So in this first one, -2 gets distributed there to make it -6y, and -2 times 1 is -2, and then the plus y just drops down. You'll notice that you have two like terms, -6y and y, because the same variable y is raised to the same power, 1. So you combine those, you have -6y's and 1y, so you now have -5y, and the -2 stays. So this would be most simplified. In our second equation, the 4 gets multiplied by 2 to get 8, and the 4 gets multiplied by -a to get -4a, and the -a drops down right there. I see two like terms, -4a and -a, so you have -4 of them and -1 of them. These combine to make -5a, and the 8 drops straight down. You can write it as a minus 5a, that's fine. Next, we have 2 being multiplied by 7. The 12s drops straight down, so you have 12s plus 14, which is 2 times 7, and then 2 times -s is -2s. And then I see like terms here, 12s and -2s, because s is being raised to the first power in both cases. This goes to 10s, and the 14 drops down, so you have plus 14. I hope you found this video useful.